Namaste guys. In this course, you are going to learn about SolidWorks simulation. Okay, so if you are a beginner and never touched the SolidWorks simulation and have no idea how the SolidWorks simulation works, then this is the right course for you. And the best part is it is absolutely free. Okay, so you are going to learn a lot of things, why we do some things, what are the reasons, etc. A lot. And this course is designed for beginners. Okay, so let's see how to do SolidWorks simulations. Okay, and before going further, there is a timestamp link in description. You can check it out. And if anybody able to support this channel financially, I will be thankful. You can also check out my other courses. For example, if you want to learn about SolidWorks designing course, it is totally free of cost that is available. You can check out the link in description. And if you want to learn about SolidWorks animation and motion analysis, you can also check it out. Okay, its Udemy link is in the descriptions. I will be very thankful if anybody buy the course. Okay. Uh, Namaste guys. In this course, you are going to learn about SolidWorks. In the first chapter, you are going to learn about basics of animations like explode view, as you can see now, and you will learn about how to change color and appearances animation, how to make mechanism. Here, as you can see, a offset crank mechanism, how to make a 4-bar mechanism and analyze its trace path, okay, and how to make it more correct. We will also plot various kinds of things like acceleration, velocities and other parameters in a 4-bar mechanism. While analyzing, we will calculate how much torque or energy required in a certain mechanism in SolidWorks motion analysis. After all this, we will learn event-based motion analysis that is very important in real life for making animations of robots and machines. You will also learn what are the different ways to animate, and everything is covered in this course. Really guys, I will thankful if you buy it. Okay, so let's start. So first thing what I have to do is I have to do the simple simulation of it. Okay, so if I go here, I will look here. You will see there is no SolidWorks simulation tab here. So what I need to do is go to SolidWorks add-in. Here you will see SolidWorks simulation. Okay, other way to see that, go here, click on add-ins and go here. You will see SolidWorks simulation. Just in case if it is not visible in your SolidWorks, it means that you doesn't have installed it. Okay, so you need to reinstall your SolidWorks with SolidWorks simulation. So close this and click on SolidWorks simulation. When you click on it, wait some little time and a simulation tab will pop up. Click on it. Okay, when you first see, you will see all these kind of options are basically blocked. Basically you are not able to use it. So first thing you have to do is to define a study type. What kind of study you are going to do? So click on here, click on new study. Okay, just in case if anybody wondering what is study advisor, when you click on study advisor, here you see it basically guide for the beginners how to do SolidWorks simulation, but I don't want it, so yeah, ignore that. So click on here, click on new study. So here you can see different kind of studies that we can do. So in this course, we will talk about static, thermal, buckling, probe test, fatigue, okay, and design study, linear, non-linear simulations, okay. So we are going to cover all these things. I'm not covering pressure vessel design and one more thing and frequency, okay. So I'm not covering these two topics, okay. And I will also cover use of 2D simplification in SolidWorks. That is a very important thing if you ask me. So let's see about static simulation. So first thing that is covering is static simulation. So as the word I said static, the first thing that arises in your mind, static means that a object that doesn't move from its place. Okay, so static simulation is basically done on frame or anything that basically remains steady at its place. Okay, so this is where we will use static simulation. There is no linear simulation as well, that basically you can use with no linear objects. Okay, uh, and as we go further, you will realize how big this tool and amazing these tools are. Remember, the complexity of the course will increase with respect to time. First, I will teach simply, but with respect to time, the complexity will increase. So make sure that you fully listen what I say. If you have doubts, simply comment. So click on static simulation because I'm going to do simple static simulation. Click OK. Now, first thing we need to understand boundary conditions. So what is a boundary condition? So boundary condition is basically that condition in which environment you are doing and what is the condition of your operators. For example, is I'm doing simulation in a hot environment or cold environment because it affects the life. For example, if you take your steel in a negative temperature, you can make it brittle material. For those who are wondering how is ductile material can convert into brittle material, ever saw the movie Titanic? So basically, have you ever wondered why Titanic sink when it collide with the ice tip? Why don't the ship just bend it? Why it brittle down? Why it just broke down there? The reason is that at that moment engineer learned that at very low temperature that ductile material will act as a brittle material. That is the reason Titanic sink. Okay, they discovered this kind of discovery on Titanic case that your steel metal material basically will act as a brittle material at low temperature. So you need to make sure what are the conditions on which you are running your experiments and where it is fixed, where it is moving, etc. other things. Because if you doesn't consider one part, you are getting trashy results. Just in SolidWorks, if you put garbage in your input simulation, then you will get garbage as a output results. So make sure that you put a good amount of data in which environment you are doing. Okay, so here you can see my static. So first thing here is my part. So first thing I need to define is what is the material of my part. So simply right click on it. Here you can see apply material or apply favorite material. If I click on apply material, I can apply any material as per my requirement. Okay, you can see various kind of colors, other parameters here. View. Okay, I don't know why it's not showing. Positions issues. It's not currently showing. I don't know. Mm, they are graphs. I don't know where are those graphs currently. View. So here you can see different kind of materials available in my SolidWorks simulations. Okay. So you can choose any material as per your requirement. So choose whatever material you want. If you don't want any material, you can also create custom material as per your requirement. Simply right click on it, click on new library and you can create your own. But this will cover later onwards. Okay. So suppose I select the steel because I am doing simulation of steel and I select this steel. You can see various kind of properties. For example, elastic modulus, Poisson ratio, mass density, okay, and other things. Click on apply and click on close. Here you can see on my part name, you can see carbon steel pop up. And here one thing you notice that a check sign is showing on. It means that this condition is satisfied and we have successfully defined these conditions. So first thing what I have done is I have defined that my material. Okay. Now second thing I need to define is constraints or connections. So if I right click on it connections, you can see uh, there is nothing that below connections. Basically there is arrow, little arrow, you will see in electron words. So connections will use when there are more than two parts in your design. In my case it is a single part, so I don't need to define connections. Connections to basically what is the relation between two parts. Okay, are they rigid, are they connected, are they bonded with each other? Don't worry, you will learn about later onwards when you will see later onwards my videos in deeply how connections are, and trust me, they will burn your mind when you will see how to use connections. Okay, it is a simple things currently, but later on it will uh, burn your mind. Next thing is fixtures. So what is a fixture? So as the name suggests, fixture basically defined where it is fixed. Okay, so in this video I am just basically doing cantilever simulation analysis. So we know in cantilever one side is fixed and another is free to move. Okay, so is there any side fixed? The answer is no, because I doesn't define which side is fixed. So we can define it by using fixture. So right click on fixtures, you can see fixed geometry. So select a face. Okay, so in that way you can make this face fixed. So when we do simulation or apply load, this face will not going to be moved. Okay, you will also see advanced options, but this will cover later onwards video. Okay, so we will use simply standard fixed geometry. Click OK. After that, in a cantilever beam, we know that there is a load applied. So how to put a load? So what you need to do is either you can right click on external loads and apply from here, or you can go here and apply force. Just to know, you can also go to fixed advisor or fixtures from here as well. So click on here, click on force. Now, first thing it will ask, what is the face, edge or vertex? For example, here you can see I just moving my mouse here and it automatically selected the face. If I select the edges, it automatically select the edge, okay, as per my requirement. So as I said, it is a cantilever beam. So I will select this edge. Okay, but if I look closely, you can see it is moving this direction. But in cantilever, we know that the load acts in downward direction. So how can I define the direction? So to define the direction, click on selected direction. Okay. Now it is asking in which direction you want to put the load. Select edge or face. So I want to apply the force in this direction, downward. So select this edge. Here you can see the arrow is showing now downwards. Now next thing we need to define what is the magnitude of the force. For example, if I type 500 Newton, so the 500 Newton is force is applied on here. Okay. Let's say it is 30 Newton. Okay, because it is a very small part, not a very big part. That is the reason I'm applying 30 Newton force. Now somebody say how much 30 Newton is. Simply divide 30 by 9.81. You will get your values in kgs. Okay, remember I am using SI units, not PSI, that is inch pound seconds or PSI, I guess. So all the units that are used here are in mmgs or SI units. Okay, so I applied a load of 30 Newton. Click OK. After that, here's another thing called mesh. So this thing you need to understand very carefully, because if you don't understand what is mesh, then you are just wasting your time learning this. Okay, mesh is very important thing in SolidWorks. So let's try to understand what it is. So if I right click on it, click on create mesh. Here you can see coarse and fine. So if I increase the fine, click OK, you can see I got these number of triangles here. Now if I right click on it, click on create mesh, but decrease the coarse size and click OK. So you can see the number of triangles is decreased now and their size is big. But which one is better, bigger size or smaller size? So if I right click on it, create mesh and increase the size, click OK. So smaller one. So the answer is the smaller ones. For those who are not understanding, consider these points where these are joined are called vertices. Okay, so higher the number of vertices, better will be the result. If you don't understand how higher the number of triangles will get you better results, look at this program that I have made in Python. So here you can see my code. So this is a sine graph. Now here only 4 points are shown. Okay, but if I increase the number of points, you can see my accuracy of the graph increase. Okay, similarly, higher the number of points will increase, better will be the your result of your simulation. But it has a drawback, that is that it will consume a lot of time in your simulation. So you need to increase or decrease the mesh size as per your simulation requirements. Okay, and here you can see that if I decrease this, I will get a very low value or garbage value. For example, let's say 3. So this is how my sine graph looks like. For 5, this is my sine graph. For 8, this is my sine graph. You can see the code. It is very small code. It is written by me. Okay, 20. Just to know, I have many other channels as SolidWorks, so you can learn. If you want to learn, you can learn from it. And if you want to learn about machine learning and artificial intelligence, that I also learned that, but still unemployed. my bad luck. So make sure don't learn Python if you are not getting any kind of job. Don't be like me. Okay. So yeah, so let's again move to the main topic. So higher the number of mesh, you will get better results. Okay. After that, you need to run this simulation. So what you can do is run this study. Okay. So click on run this study or simply click on here. When you click on run this study, it will do the calculation task. Here you can see my simulation is done. Now, first question that arises in your mind, okay, the simulation is done, but it is quite bendy. Okay, so if I click on it and right click on show, you can see stress graph. Okay, this is the high stress and low stress. Right click on displacement, you can see URES engineering strain or displacement. Okay, my displacement graph. What is the displacement I get? I get 1.06 10 raised to power minus 3. Remember, it is minus 3. But you're wondering if it is true 1.06 10 is power minus 3, the scale look quite odd. I mean, it doesn't look like it is 1.06 10 is power minus 3 because I definitely can't see that small diffraction. So here's the thing. Whenever you do simulation in SolidWorks simulation show 3000 times or 5000 times the actual deflection. The reason is that so you can visualize it where is actually deflecting. If it is actually show 1.06 10 to the power minus 3 deflection, you will not able to visualize where is deflection. So that is the reason SolidWorks showing in this way. Okay, you can also see strain graph. Okay, just you know that I will cover in more detail how to do animation and other things later onwards. So that's for all in this video, and make sure you check the timestamp to learn about particular things. So I hope you learned something from this video. Thanks for watching and have a great day. Namaste. So namaste, in this video I'm going to tell you how to do static simulation in SolidWorks. So first of all, I'm going to draw a sketch as per my requirement. So I'm just creating an I-beam. You can create I-beam as per your requirement. You can customize whatever you feel like it's good for you. So here select this line at the center, enter the value of 10 mm and 100 mm, let's say 50 mm, escape, make it horizontal, press Ctrl plus Z, select these two lines by pressing Ctrl, I don't know. Make it 80 and the distance from here to here is cancel. In this point to this point distance is 40. As you can see, our sketch is turned into black. It means that our drawing is fully defined. Now go to fixtures, click on extrude. Now select mid plane and then extrude up to 1200 mm. Make sure you select these things, click OK. After that, go to SolidWorks add-in, make sure you click on SolidWorks simulation. After that, click on simulation, go to study advisory, click new study. Make sure you click on static. So a question arises in your mind, where is static simulation is used? Static simulation is used when you know that that you have a body or chassis or a beam on which a constant load is applied that is not varying with time, that is remain constant. Okay, at that time you use static load. If your load is varying with time, that at that time you use normally non-linear or linear dynamic. Okay, currently I am assuming that my load is constant and it just putting here at a constant force. So click OK. Before I start this, I need to make the area on which my whole load will act. Press Ctrl plus 8. I am drawing the sketch. Now I'm assuming that my whole load is acting on this sketch. Now here what you will see when I go to simulation, so static, and I will show you something. Okay, first exit the sketch. Now click on part, click on apply favorite material, click paint carbon stream. After that go to fixture basic, click on fixed geometry, select this face and this face, click OK. Now here comes the important thing, click on force. When I try to click on force, as you can see I am selecting the whole beam, but I just want to select this particular sketch. So how can I do that? To do that, what I need to do is projection. So what you need to do is go to features, select curves, click on project curve, select this sketch. After that in here select the face, click OK. Now you can see, oh sorry, I guess I am doing something wrong. Right click on it, delete. Yes, I need to select split line, sorry for my mistake. So select split line, and after that select this face, click OK. As you can see, now I'm selecting this line only, I'm not selecting this whole beam. Go to Solidworks simulation, sorry, static. Now click on external loads, click on force, select this face. As you can see I'm selecting this face only. Before that I am selecting this whole beam, but I don't want, I just want my load will just act on here. So enter the value of 70,000 Newton, or you can change the value as per your requirement, and make sure the arrow is acting downward direction, because my load is acting in y direction downwards, not in upward direction. If somebody say hey my load is acting upward direction, just click on reverse. As you can see the load is acting upward, but in my scenario the load is acting downward. After that click OK. Now go to mesh, right click on mesh, click on create mesh, click OK. Here you will see this is how the mesh look like. Now right click on mesh, create mesh. Finer the mesh, the better the quality of the result. You can adjust the parameters like what should be the width, height, depth of your mesh parameters or nodes as per your requirement. In my case I just prefer this normally will do for me. Remember my main aim is here just to tell you how to do a simulation. Okay, so you can adjust and create whatever you want. And remember one thing, higher the mesh rate, higher will be the quality of your result, but it will also increase your simulation time etc. So I'm not going to do that. I'm just simply going to show you how to do that and how to plot graphs and other things in SolidWorks static simulation. Now click on run this study. When you run this study, what will basically happening, that is calculate. Now here you see the graph. Now go to displacement, right click on it, click on show. Now the first thing you see is that the beam is bending too much, it means too much, but here you will see that the deflection is currently 4.025 10 to the power minus 1, but this is not the 4.025 10 to the power minus 1 because it is way more higher. So why is showing me like this? The reason is that SolidWorks showing is so much deflection is because so that you know where it is deflecting. If it doesn't show like this, you will never know where it's deflecting. For example, from a naked point eye of view, you will never able to detect what is point. You never able to detect 0.1 mm deflection in a 1200 mm beam. So how to see real deflection? So to do that, right click on it, click on edit definition, select true scale, click OK. As you can see, this is the true scale, this is the true deflection, but for your from your eye point of view it look like a straight beam. So right click on it, click on edit definition, click automatic, click OK. Now right click on it, click on animate. Here you can see it is currently showing me 5 frames per second. You can change the frame per second by just adding the number of frames you want, and it is telling me the number of frames showing, for example 150, but for example right click on it, animate, sorry, stop, enter the value of 60, click play. Now here you see it creating the frames 60 fps, and you can get a deep detail how does it bending and where is the maximum displacement. And now you see it's a very cool animation. From here on you get total clear picture how is going on. Now click on stop. After that, go to click on stress simulation, click on show. Now right click on it, click on section clipping. So here you can see I select a section and you can see where the load acts. You can select this section of the plane as per your requirement. Either you click on the arrow or choose the section where you want to see basically the stress in the beam at a particular point of length or width. It's quite handy, and you can take the photos from here and you can use it in your simulation analysis, or showing in your tables. 50 mm. Now let's see another thing we can do, ISO clipping. Here you can see where it's showing me the values above this value, 4 lakh something. So if you want to show the stress at a particular value, for example you want to know where is the stress above this value is acting on it, so you can get a clear picture from here by ISO clipping. It shows where the stress above this value is acting on it. You can also click plot on ISO surfaces so to get a clear picture. Now let me show you another thing. Now right click on it, click on probe, select this line. Okay, I'm selecting this edge, click on graph. On select, make sure you click on selected identities. Sorry for mistake. Now select this line, click update. Now click on graph. As you can see, it shows me a clear picture how does my stresses is acting on this line. Remember, this line is just this long, not the whole beam. You can select the whole beam as per your requirement, but I'm just showing this stress. Here question arises in your mind. The stress is basically plot in one misses stress and parametric distance. Parametric distance is nothing but that I told you previously, the mesh length, width. Remember, this is what the graph plots. The number of triangles here, it plots basically on that. That is what is statically nodal stress. Or you can save this file and use it in your Excel or sheet or somewhere as per your requirement. You just click on save, you will get that one. Now last thing is strain. Strain is basically, as we know, change in length upon original length. That is what we call strain. So you can animate it. Remember, all the parameters here showing are basically 200 times or 500 times than the original. So if you want to change it, I already show you how to change it as per your requirement. And here the frames are 60 fps. So fps means frame per second. So it gives you a clear picture how this animation goes on. Click on stop. Now click exit. Now click on plot tools, and you can save as this and or animate it. Plot tools, click save as. You can save the analysis in e-drawing files as per your requirement if you want. Okay. And section clipping. Section clipping is the same thing as I told you. If you want to see where is the strength at any point, length, width, or anywhere else, that is this. You can easily see from here. Here you see the triangles here. So basically these are the nodes that I told you. They are basically the mesh size. So because of the mesh size, these triangles are showing on. If you want to reduce them size, just reduce the size of your mesh, and you will get a much better result from here on. And if anybody want to learn how to do nonlinear simulation, if anybody want to learn how to do nonlinear simulation, so here is a video. You can see how I'm doing a non-linear simulation. You can get many things as a result. The link the link of this video is in the description. You can watch it. I hope this video is useful for you. If you have any doubts and queries, make sure you ask the comments. Thanks for watching and have a great day. Namaste. Namaste. In this video, I'm going to teach you about advanced fixture in SolidWorks. So first, let's see our geometry. So here, I just make a simple a cuboid. Okay. So let's see what is the advanced fixtures in SolidWorks. So click on new study, click on static, click OK. After that, right click on this, apply the material as per your requirement. I am going to apply plain carbon steel, okay, but you can choose any other material as per your requirement. Now right click on fixtures, click on fixed geometry, select this face, click OK. So go to fixture advisors, click on advanced fixtures. So in this video, I'm just going to talk about on flat faces. If anybody want to learn on cylindrical faces, you can check out the previous videos, link in description. Okay. So here the first thing we need to do is select a flat face. Okay. Now suppose somebody want to select a curved surface, then you need to select on cylindrical faces. Okay. For flat faces, basically we use this. Okay. On flat faces. Now let's see what does these things do. As you move up, you can see the animations showing what these things do. As you can see, these are showing upward, downward and lateral. Suppose I click on this and enter a value of 5 mm. So basically what it means that this face will move down to 5 mm. Okay. Click on OK. Click on run the study. Here you see I got a simulation result, and if you notice correctly, I doesn't apply any kind of load. What I have done is I simply told SolidWorks that move this edge to 5 mm, and you can see for a particular distance it tells me how much stress is generated here. As you can see, the value is quite large, 4.71 times to power 8. Okay, now let's see another options. So click on edit definition. If I click on here and enter the value 0 mm and make sure it is also 0 mm, click OK and run the study. You see that my graph is changed a little bit. So questionnaire what happened, what basically happened here. So basically when I put 0 mm and 0 mm, it means that it can move downwards, but there can't be any kind of movement in this direction and in this direction. So basically it can't compress and it can't be shear load. Okay, that is the reason I got it. Oh, this kind of stress. A question arises, what is the advantage and where these kind of things are used? Suppose you have a beam, you know that your beam is going to deflect by 3 mm and you want to calculate how much stress is generated due to the certain displacement. At that point, you use advanced fixtures. There are many other instances as well, for example, vibrations, or you know that the amplitude at which it's going to vibrate. You can also use there to calculate the stress. Okay, remember these kind of advanced fixture mostly used for simulations, for stress strain calculations. In this, you basically doesn't apply any kind of load. You basically give a input value. For example, here 5 mm I give it and calculate what is the stress generate. Okay, so this is where we use advanced fixtures. If anybody have any kind of query and doubt, you can just check out the link in description, and make sure that you like us on Facebook so that our Facebook channel can grow and give you more educational knowledge. Thanks for watching and have a great day. For any kind of query and doubt, just comment. Okay, namaste. Namaste. In this video, we are going to learn about advanced fixtures in SolidWorks. So to understand advanced fixture, we need to do some simulation. So here I'm going to do a bevel gear simulation by using advanced fixture. So let's insert our bevel gear. So bring it in. Okay, and make sure that you have the same properties as here. Module is 2, number of teeth is 25, and gear number of teeth is 25, and this. After that, what you need to do is click OK, close this, right click on it, click on Open, click OK. Now, click here, click on Save As, click on Save As Copy and Continue. Make sure that you save this file on desktop or any other place but not on C library, okay? And change the name, okay? Click Save. After that, close this. Make sure that you don't use this in simulation because if you do any kind of changes or save this file, it will become permanent in your library and you will not able to use Bevel Gear in future onwards. And it is quite messy things. So I highly recommend don't do this kind of stupidity because I have done this and I regret. Now close this as well. Don't save. Now click here. Sorry. Click on here. Click on assembly. Click OK. Now click on browse. Open the part that you have saved recently. OK. Click open. Now right click on it. Click on show. Right click on this part. Make sure it's float so that we can move it. And let's make some mates. Select this mate. Right plane. Sorry. Let's make it some oriented incorrect. Now select this and this face. Click OK and select this and right plane. Click OK. After that, press Ctrl and right click on this part and drag this. Now click on mate. Select this point and select this point. Okay, they are considered each other. Rotate. Now make it like this. Select this point and this point. Click OK. Now right click on this part, click on fix. Move this part upwards and make it little orient as per the requirement. Click here. Sorry. Now hide the sketch. Now let's do advanced simulation. Now click on Solidworks add-in, click on Solidworks simulation. Now after that click on simulation, click here, click on new study, click on static, click OK. Now give the material as per your requirement. I am giving plain carbon steel. After that right click on this, delete because we don't want it. Right click on collections, click on contact set. Click on no penetration. Select this one and the second one. Sorry. Right click on it. Click on component contact. Select this one and this one. Make sure it is no penetration. Click OK. After that, right click on it. Go to advanced fixtures. Okay. Now, here you will see there are different kind of fixture, advanced fixtures. Cyclic, use reference geometry, on flat faces, on cylindrical faces, and spherical faces. So here these are cylindrical faces. So I'm going to teach only about on cylindrical faces. Okay. So if you go downward, you will see these three things. Let's try to understand what these things do. So here you can see this one basically means axial, this one translating, and this one is rotation. So here if you hover your mouse, you can see it's radial, circumferential, and it's axial. So basically what it means radials, for example, click on it, select the cylindrical face. So if I click on radial and give some value, for example 0 mm, it means that this face can't move uh, in this direction. Okay, so it means this face can't move in this direction, sorry, in y-axis. So when I enter the value 0 mm, it means that this face has a constraint that it can't move on y-axis. Okay, and if I click on axial, you can see this arrow. So it means here you can see it returns 0, 0. So it means that this can't move in this direction as well. So the only thing it can do is rotation. I'm You can also put the value of rotation. I'm going to put, let's say, uh, suppose I want to rotate the gear 5 degree. So 5 into pi divided by 180. A question is why the hell I'm doing this? The reason is that all the value here are going to be in radians. So I need to enter the value in radians. So 5 degrees 0.087 radian. Okay. So enter the value. So what does it means that my this gear is not going to move in x-axis, y-axis. It can only rotate 0.087 degree. Okay. Remember, it is a very important to use advanced fixtures because when you do real life simulations or advanced simulations, you are going to use mostly advanced fixtures because they are the main parts. Okay, click OK. Now, right click on fixtures, click on fixed geometry, select this, click OK. I'm assuming this one is fixed. Okay, now basically the main aim is that I want to know how much stress is generated. So what I can do is simply click on run the study. Now it will going to do first meshing. After that, we will run the simulation. Now simulation is done. So you can see the results, and here you can see this test string. So a question arises where these kind of cylindrical faces are used. For example, when you are sure that your part cylindrical face is going to rotate up to this level of degree or going to move in x or y axis up to certain and you're not sure about it and you want to calculate how much stress is going to generate for that things, you are going to use advanced fixtures. When you apply the load, you will get to the value of stress and strain and what is the displacement. But when you apply the fixtures, you basically calculate what is the stress generated when your part extend, rotate up to this degree or extend. Okay, so this is what here is done. Here my gear rotate 5 degree and I what I have calculated is the stress. Okay, so I hope you learned something from this video. If you have any doubts and queries, please ask in comments. Thanks for watching and have a great day. And more cool videos are coming. First thing we have to do is go here, click on in asymmetric, click on power transmission, click on gears. Now first we have to draw internal spur gear. Okay, uh, let's wait. Now choose the module, number of teeth, and the, let's say, the thickness, the face width, let's say it is 30 mm. Okay, now click OK. Now close this. Now what we need to do is select this, click on spur gear, import it. Make sure that the module is same because this gear has a module 2, so this one will also going to have a module 2. Now make the number of teeth be 30. Move downwards. Let's say face width is also 30 mm. Click OK. Now close it. Now select this face. Go to the mates. Select this face. Click OK. Select this and press Ctrl plus 8 for normal screen to the view. As you can see, they are not much, they are not totally coincide. So what we can do is simply click on it and drag it little bit here. Okay. Just to know that we are going to do simulation, not motion analysis. So I don't need to define lots of mates here. Okay. So what we can do is go to Solidworks add-in, click on simulation, and hide the Solidworks flow simulation because I'm not doing any kind of flow simulation. Okay. Now after that, what we need to do is go to your simulation tab, click on here, click on new study. Let's say it's a static one. Click OK. Now we have to define some constraints. So select this and go to advanced fixtures. Uh, Click on cylindrical faces. Okay. So select this face and move downwards. So now try to understand what are the different constraints and their meanings. Okay, so if I select this, so it means that it is not going to move in y direction. As you can see, the value is 0. It means that it is not going to do y direction. Here you can see this gizmo. So this axis is defined y axis. If I select this, it means that it is not going to move in x direction. Okay, because if it is move, then I will get a wrong results. One more thing that we have to do is I also want that this gear will not rotate. So what I can do is select this and click and apply 0. Okay, click OK. After that, what we need to do is go here, click on advanced fixtures again. So select cylindrical face, select this internal face, go downwards, select this one 0, and select this one is also 0. Now I want to rotate it up to 3 degrees. Now p into pi divided by 180. So it is 0.0523. Just to know that all values that you put in SolidWorks are in radians units. So you need to make sure that you put the value in radians. Okay. Or let's say we wanted 5. 5 I think is much better as compared to 3 degree. So 5 into pi by 180. It is 0.0872. So click on here, enter the value of 0.0872, 0.087. Click OK. Now what we need to define is we need to define the material. So right click on it. They all have plain carbon steel, but if you want to change the material, you can change it as per your requirement. Now here another thing, that is component contact. So right click on global, click on delete because we are going to define our own. So right click on connections, click on contact set. Make sure that is no penetration because there is no penetration between them. Okay. uh, Instead select this, right click and click on component contacts, select this one and this one. Make sure there is no penetration. You can also add friction as per your requirement. I am adding a friction of 0.05. And let's try to do the simulation. Select this face, press Ctrl plus 8 and click on run the study. If you want, you can also change the mesh geometry as per your requirement. But in my case, I'm not doing any of these things. It might take some time to do the simulation, so you need to keep calm and watch the show. So our simulation is done. Let's see the results. So right click on displacement, click on show. So as you can see, the gear has a lot of stress. Just to know, if anybody wondering why there is no stress on these gear much, the reason is that this gear has a fixed geometry. It means that this geometry is not going to move or anywhere else. That is the reason you are not able to see much stress here. Okay. But if you zoom in, you can see the teeth here are getting stressed, and you can also get the value of what is the maximum stress, that is 4.69. And it takes a lot of time in my PC as well, so do do a favor on yourself, do the simulation on a good PC, not a PC like me. Okay, now right click on it, you can define plot factor of safety. Okay, for example, all bodies, and set the upper limit to 10. Click OK. So factor of safety, you can see. So here is a lot of stress, so you need to do work on it. Okay, so I hope you learned something from this video. Just in case, I have already teach a lot of times how to plot graphs and other things. So if you want to learn how to plot graphs and various points and values in this case, similarly what you can do is just check out the link in description of my various SolidWorks simulation courses where I've explained these things a lot of time. Okay, so you can watch it there, and I've explained it very briefly, calmly. You can watch it. And if you have any kind of doubts and queries, make sure that you ask in comments. And if you have any kind of special query, you can message me on my Facebook page. Link in descriptions. And I hope you learned something from this video. And make sure that you like, subscribe and share this video to motivate. Thanks for watching and have a great day. Namaste. Namaste guys, in this video I am going to show you how to calculate stress strain when a torque load is applied. Before I start this video, make sure that you subscribe our new channel Mechanical Coder and Engineerknow for better understanding of engineering concepts. Okay, so let's get started. So first of all, select the front plane, click on sketch. After that, first thing we are going to do is we are going to make a shaft. So select a circle, draw a circle. Okay, now give it a diameter as per your shaft requirement. Let's say 90 mm, or 90 mm is too big. Let's say 40 mm. Now go to features, click on extrude boss base, click on middle plane. Now increase it as per your length requirement. Okay, click OK. Now after that, go to simulations, click on new study, click on static, click OK. Now apply the material as per your requirement. So I am applying plain carbon steel, but you can choose any other material as per your requirement. Next thing is fixtures. Here you see a options called connections. Connection is basically used when you have more than one or two part, or you have parts or features that are not merge with each other. Okay, so here is the fixtures. Fixture basically mean what you want to fix or move. So right click on fixtures, click on fixed geometry, select this face. So basically what I'm telling, that select this face, and this face is fixed. This face is not going to move. This is what it means by fixed geometry. Click OK. After that, right click on it, click on, sorry, now right click on external loads. As I told you, I am interested in torque. So select the torque, select this face. Okay, now it is asking for a axis or cylindrical face. You can select this face again, but here you will see that it is selecting the whole shaft. But I just want to put a load at this particular, for example, say a small strip of area. So how can I do that? So to do this trick, go to first model, select the select the top plane, click on sketch, press Ctrl plus 8 for now I'm asking to the view. Draw a simple line. Now exit the sketch, go to features, click on curves, click on split line, select this, click OK. So you see I got a face selected. Click on static, Click here, click on torque, select this. As you can see, I'm not selecting the whole, I'm just selecting a particular face. So this is what I want basically. For example, if you are making your car or shaft, okay, so there is basically a particular face that basically facing all the torque, okay, and this is just a rigid body. So apply the torque as per your requirement. Let's say 500 Newton meter, okay, and you can reverse the direction if you want. Click OK. After that, either you can right click on mesh and create the mesh as per your requirement. But in my case, this mesh is, for example, if I click OK, as you can see, this mesh is quite fine. So this will work for me. Okay. Now click on run the study. After simulation, you will see this kind of result. A first question arises in your mind, what the hell is this? And why it is too big? So basically what happened when you do stress strain simulation, Solidworks show the results 500 times or sometimes 200 times higher than the original. For example, if I right click on it and go to chart options, go to definition, you see this is automatic. This is 209.507 times the original. If I click on true scale and click OK, so this is the original. And if I right click on displacement, click on show, again right click on it, click on uh, chart definition, definition, true scale, click OK. So here you can see. So this is the maximum strain. Suppose someone asks, hey man, uh, where is the maximum stress or minimum stress? So check out these options here. I'm currently in strain tab, so I will get the value of maximum strain and minimum strain. Oh sorry, first right click on it, show, right click on it, click on chart options. So here you can see, so here the maximum stress is happening and here is the minimum stress. You can see just by the point, okay. So this is the what I like about solidworks, that is basically telling the point exactly where is the maximum stress and where is the minimum stress, okay. I hope you learned something from this video. If you want to plot the graph from this video, from this sorry simulation, you can check out my other links, other videos, link in descriptions. Thanks for watching and have a great day. Make sure that you subscribe our other channels for better understanding of engineering concepts. Thanks for watching and have a great day. Namaste. Namaste guys. In this video, we are going to see how to calculate fatigue. So before I discuss about fatigue, let's try to understand what is fatigue and why there is need to learn it. So basically fatigue tells what is the life of your product and how much your product is going to last. Okay. You can say the quality of your product. So here, what I have done is that right click on edit definition, that I have run my cycle 1 million times. So what 1 million times? A question is what is 1 million times? So what I have done is that I have applied a load of 3000 Newton, okay, at this end, and this side is fixed. And due to that, I got some results, stress strain results. Okay. So this is my stress. Remember, but this happen only one time. What if I do this thing applying load 1 million times, 10 raised to power 6 times? Okay. So what will going to happen by this part and how much stress, strain or damage it will going to face? Okay. This is what we call fatigue. There are many parameters how to calculate it. I also have done Python coding for on it, how to do on it. Okay. And you can check out the link in description. And so let's see how to do this simulation. Okay. So first click on here, click on part, click OK. First thing we need to make is make our part. So let's make the part, escape. I'm going to make a hollow pipe. Now, here see I have made this pipe and this thing. So the main purpose of split line is just to make this face so that I can apply load, nothing else. Okay. So now go to SolidWorks simulation. Okay. Click here. Click on new study. To do fatigue analysis, you need to do first a simulation. Okay. If it doesn't do any simulation, you can't able to use fatigue. So click on static and click OK, because first we are going to do for static simulation. Now first thing we need to define is what is the material of our product. So click on apply edit material. Let's say I'm choosing AISI 1035 steel. Okay, apply, close. After that go to fixture advisory, click on fixed geometry, select this face because this face is fixed, and click here, click on force, select this face, click on selected direction, select the top plane, select this, enter the value of 3000, click on reverse direction. So click OK. So let's try to understand what I have done in static simulation. So basically I am saying that I have a hollow pipe whose one end is fixed and at the other there is a load of 3000 Newton is applied. Okay. Now if I click on run the study, I got this result. Okay, so you can clearly see where is stress, where is high stress and whatever things. Okay, now let's try to do static simulation. Now click here, click on new study, click on fatigue okay, now there are different kind of fatigue simulation. The first one is constant amplitude. What is mean by constant amplitude? Constant amplitude means that the stress is happening 3000 Newton. Remember that I have applied a load of 3000 Newton. When a constant amplitude load is applied, it means that throughout my cycles, the load is 3000 Newton. Okay. The other one is variable amplitude history data. This one you will use when you have done experimental data and you have some data to do in real life. There are other ones, harmonic fatigue. This one, if you have some function of your load data. And the last one is random vibration. This is one little complex, but I will cover some other later on videos. Okay. But in this case, we are going to learn constant amplitude. So click OK. Now, first thing we need to do is define loading constant amplitude. So right click on it, click on add event. Here you will see different kinds of option: fully reverse, zero based, loading ratio, find cycle peak. So fully reversed means that 3000 Newton load applying in the downward direction as well 3000 Newton load applying in the upward direction. Okay, so this is what it means fully reversed. Zero based, it means that only 3000 Newton load applying in downward direction, there is no upward direction. And loading ratio, you will define how much load is acting downward and upward, you will define a ratio basically. Okay, and find cycle peaks, this is other one we will talk about some future onwards. We will define the number of cycles. Okay, for example 1 million, so at three zeros, so this is 1 million. Click OK. Here you will see the part option, so right click on it, click on apply edit fatigue data. So you will see like this. So first you need to define a SN curve. So SN curve basically tells that how much the life of your product is. Basically whatever simulation you are going to do, it is basically going to define by SN curve. Okay, so click on file. So basically I am doing simulation on steel. So select the material. Okay, I'm selecting steel. Click OK. Here you can see the SN curve. I highly recommend that you please check out my blog link in description for better understanding what is going on, else you will face problems. And there is also a Python code on it how to calculate these kind of thing in Python. Okay, click OK. Sorry, cancel. Click apply, close. Now what you need to do is click on run the study. So after I have run the study, you will see something that I got some results. So right click on it. Here you can see other kind of things called life, damage, load factor. So if I click on life, so here you can see the red part has a life of 1.037 10 to the power 5. A question arises, most of you not able to visualize what is mean by 10 to the power 5 or cycles. So suppose like this, suppose I have a bearing who have to rotate 10 revolutions per day. Okay, remember it is rotating 10 revolutions per day and it has a maximum life of 1000 revolutions. It means that maximum it can rotate 1000 revolutions. So if I want to calculate what is the life of my bearing, it is very easy. It is 1000 divided by 10. So I can say that the life of my bearing is 100 days. So similarly, here I got in cycles. So if I know how much the load or cycle my part is going to face in a single day or a job, I can easily calculate the life of my products, whatever it is. If you see, I ever saw advertisement like it say, hey, I give you 1 to 2 years, 5 years. So basically, they calculate what is the cycle of your product. Okay, Uh, based on that calculation, they calculate what is the guarantee and life period warranty they will give you. So if I right click on it, fatigue component, click on damage. So here you can see, here you get the maximum damage. Here you get a damage of 96.44%. Okay. Similarly, you can see other options, load factor, edit definitions, chart option, show minimum. So here you will get the minimum and here you will get the maximum load factor. Okay. Similarly, right click on it, damage, select this, right click on it, click on edit definition, chart option, click on show maximum. So here you can see, here you will get a maximum stress or maximum damage. Okay, I'm showing the maximum damage graph. So here you, at this point you will get maximum damage in your pipe. I hope you learned something from this video. I have posted a link in description about the blog where you can learn about what is SN curve, what are its advantages, how fatigue life calculated, and Python code, etc. So you can check out the link in description for better understanding and knowledge. I hope you learned something from this video. If you have any kind of doubts and queries, make sure that you ask in comments. Thanks for watching and have a great day. Namaste.
Namaste. In this video, you will learn how to do optimization or design study in Solidworks. So first question arises in your mind, what is the need to do design study or optimization in Solidworks, or what is its real application? For example, as you can see, this is a I-beam. Now, when you go to a vendor and ask for the vendor's price, it will say it will charge you on the basis of mass of iron or material that you are gonna buy. Because of that, it will gonna increase the cost of your production or your product. So how can you reduce the cost of product? By reducing the weight of the I-beam. But when you want to reduce the weight of the I-beam, you don't want to compromise its factor of safety or maximum stress it can handle, because it will gonna impact the quality of your product. So basically optimization is used to enhance the quality but reduce the price or cost. So in this video we will learn how to do it. Remember, to do this optimization, first you need to do is check out my previous video in which I told you how to do static simulation in SolidWorks. Remember, without that you can't do whatever I'm doing in this video, because to do design study you need to do first a simulation. After that you can do design study. So to to do design study, click on the study advisor arrow, click on new study. After that, select design study, click OK. Now here you see it is asking variables. So a question arises your mind, what is a variable? So click on add parameters. Here I already selected the parameters, so let me tell you what are the parameters. Parameter is something that we are going to vary so that our so that I get the less, so you can say I get good factor of safety or stress at a less mass. So let's add parameter from the sketch. For example, click here, delete, delete, delete. So now select this width 100 mm. Now name it so it will make easy for you. Now type enter. After that, select another row and select this 20 mm. This is basically the depth, or sometimes called flange of width or something else. And at last select this depth. Okay, depth, and this thing is called thickness. And this is called let's say this is called depth. Now click on apply and click OK. Now add other parameters, depth and thickness. Here you see a value of minimum, maximum and step, and here you see range with step, discrete values, range. So range with step, basically currently we are seeing is minimum value, maximum value and step value. So basically what's gonna happen when I do the simulation, it will start with the conditions that my width is 50 mm, and at that time my depth is 40 mm and my thickness is 10 mm, and it will run a simulation on in these three parameters. Now when it satisfies these three parameters, it will now run a simulation where my width is 50 mm, depth is 120 mm and my thickness is 10 mm. In this way it will do a permutation combination like thing, and we get the result. Here you see it will run a total active scenario 27, but as you know my width is total width is 100 mm, so I want that my minimum width is remain 100 mm and depth should be at least 80 mm, because I want that the scenario it don't affect, and thickness to 10 and 30 mm. Now a question arises in your mind, why I am selecting the step value 50 mm. Maybe some people don't understand what is mean by depth 50 mm, 40 mm, 10 mm. Don't worry, when I run this simulation you will realize what it means. Now click on add constraint, click on add sensor, click on simulation data. Remember, you can only use simulation data when you have already run the simulation. If you don't, then you can't do this design study. Click OK. Now here it is asking what is the minimum stress, maximum stress, or in between. So basically I want that my stress should not go beyond 50. So click on less than, because I don't want that my stress go above 50 Newton per mm square. So it will decide, so it will run this simulation and see where I got a maximum stress of 50 Newton per mm square with a less weight. Now click on add sensor, click on mass properties, select this I-beam, click OK. Now here our goal is to minimize the mass. If you want to maximize the mass, just click here and click maximize, and it will do the maximization. Now remember, we have done this 100, 150 and 50 mm. Now I am going to run this simulation and you will realize what is this thing do. Now when I click on run, remember it will do a total 12 scenarios. If you want to more accurate and better result, then what I recommend is reduce the step size 1 mm in every case. But I am not doing it because when I do that, it will gonna take very long time and it is just waste for me, because my main aim here is to tell you how to do a simulation. Okay, it up to you how much quality you want. If you want much better quality, just decrease the step size 1 mm or 0.5 mm as per your requirement. Okay, now click on run. When you click on this, you will see it is starting running the scenarios. Now remember the step size here, 100 mm is the initial width and depth 80 mm, and thickness, remember thickness is was 10 mm. Now it running the simulation. Now here you can see it running the simulation. Now remember uh, what was my step size, 100, 150 mm. Okay, now 50 mm increase. Now it runs the simulation at a depth of 80 and 10 mm. If you okay, I can't go back to show you. So it is running within the variable range, and here you can see where is basically crossing my constraint. The red part is basically have stress greater than 50 newton per mm square. Because of that, it just show them red, because these results are not ideal or beneficial for me. But they also contain less mass, but they are not going to recommend me because they are increasing the limit of 50 newton per mm square. Here my simulation is done, and you can see when my width is 100 mm and depth is 120 mm and thickness is 10 mm. At that point I got a stress value of 39.126 and a weight of 5280 gram. And here are the currents. At current, my width is 100 mm, depth is 80 mm and thickness is 20 mm. What you can see is it increased my depth and decreased my thickness. Because of that, I got this value. So this is how optimization work. Here is the optimization. This is basically the current figure you see is the optimization figure. Okay, if you want the original, this is the original. Okay, and this is the optimal one. I hope you like this video. If you have any doubts and queries, make sure you ask comments, and please give me the valuable feedback, what kind of video tutorial you want and what you want to learn. I can make video tutorial as per the requirement. Thanks for watching and have a great day. Namaste. Namaste friend, in this video I will tell you how to do a conduction simulation analysis in Solidworks. So in this simulation I will tell you two kind of scenario. First is a simple body and second one is a composite body. Okay, so first I will make a simple body. So I am basically in assembly mode and click on new part. After that, select this new part and click on edit component. Expand this, select a front plane, click on sketch, press Ctrl+8. Now draw a sketch of 100 by 100 mm. Click OK and extrude it up to a length as per your requirement. Here I am taking it as a 50 mm. Okay, here is our body. Now go to simulation. First exit the edit component. After that, go to simulation, click on new study, click on thermal, click OK, right click on parts, click on apply material. Now select the material as per your requirement. Make sure you just need to check the value that thermal conductivity value is given. For example, in this scenario 50 watt meter Kelvin is given as a thermal conductivity, so I am choosing this. You can choose any material as per your requirement, but make sure you know that the Solidworks show the value of thermal conductivity, because in some cases you will realize that Solidworks doesn't give the value of thermal conductivity. So make sure you always choose a material whose value is given in Solidworks. So apply and close. After that, what I am going to do is applying temperature load. So click on temperature, select a face and click the units, for example 250 degrees Celsius. You can enter the value as per your requirement and click on thermal loads, click on temperature and select this face and select the temperature as per your requirement. Click OK. Now run this study. As you can see, it plots our heat graph. Now click on this face, press Ctrl+8, click on plot tools, click on probe. Now I am just clicking on points so that I will get basically a rough idea how does the graph flowing. Remember, it is a 1D plot, so it doesn't matter I click on at the top or I click at the bottom. It will just a 1D graph. Okay, I have done a 1D simulation and click on graph. Here you see the temperature variation. Okay, remember here the units are shown are in Kelvin, not in Celsius. Here you can see the value of sum, average or maximum root mean square value. You can change it as per your requirement, or you can have it as per your requirement, and you can click on save the result for your CSV file. Click OK. Now a main question, how to calculate heat flux. So to calculate heat flux, go to result advisory, click on new plots, click on thermal. After that, on display, click on it, select resultant heat flux. Remember, it doesn't matter what heat flow in X, Y or Z. The main thing I am focused is on the resultant. So that is the reason I am clicking on resultant heat flux. Make sure the units are in watt per meter square. Click on show vector plot to give the better how does heat flow. Now click on plot. Here you see when I click on anywhere, the value is remains same, 2.25. okay, watt per meter square 10⁵. So even if I plot a graph, you can see it is a straight line, because we know that Q is nothing, just Q equal to minus K8 T2 minus T1 upon T. If you put the values of all the things we calculate, we know, for example, K is 50, I guess the material value is 50, area is 100 by 100 mm. So you need to convert the unit. Either you convert A in meter, so that T in meter you can calculate it, because our units here are in meter square. So convert all these units in meter. Okay, and we got the value of Q. Now let's talk about the composite beam. So to do a composite beam, first go to assembly, click on insert component, click on new part, go to model, select on this part, go to assembly, click on edit component. Now select a face, click on sketch, press Ctrl+8, draw a square, extrude it as per your requirement. It is not necessary what I am showing here, you also do the same. Click 20 mm, click OK. Now exit this simulation, edit part, click on new study, click on thermal, click OK. Click on parts, select part 1, click apply edit material. So first material I am applying is alloy steel, as you see in the first case. Now in second part, click on apply material, select any material as per your requirement, for example cast alloy steel. Here we can see, wait a minute, thermal expansion, what I want is, here we can see the thermal conductivity value is 38 watt meter Kelvin. So apply and close it. So we basically defined two materials. Now go to thermal loads, click on temperature, just select this phase. A question will arise in your mind, what will happen if I select this phase and this phase? Just remember, if I select this phase, top phase and side phase, then my simulation will become a 2D and 3D. For example, If I select this face, now my simulation become 2D. Now, if and I get the value of Q different at different points. It will not same at all over the points because now my simulation is 2D. If I select all three faces, my simulation become 3D and I will get a different value at every point, even in the inside. So choose as per the requirement. Here I am just showing a simple 1D simulation. Okay, click Celsius, enter the value of Celsius as per your requirement. Again click on thermal loads, click temperature, select this phase, select units Celsius, click OK. After that click on run this study, and here we got our graph, our plot. Now for example, if somebody want to see somebody want to plot how does the temperature is changing, so just click on it and select the locations. First delete all clear selections. Now select point by point. Remember, the points more close are, the more better and accurate graph you will get. Now go downwards, click on graph. Here you see a sudden decrease. It is because the gap here is quite big. If the gap is not that big, you will see a straight line. Okay, because of that the distance is not same here at here. Because of that it is not a fully straight line. Now let's see how to see heat flux. So click on temperature, click on heat flux resultant, click show as vector plot. Let's check, let's see without vector plot. Click OK. Here you will see the heat flux vector plot, heat flux plot. Click on probe, click on it. As you can see, the values remain on the same at all points. It doesn't matter where you click. Go to graph. Here you can see the value remains constant. If you like this video, make sure you like, subscribe and share this video. More tutorial on heat transfer are coming. I hope you like this video. Thanks for watching. Make sure you like, subscribe and share, and watch our other cool tutorials, for example no linear simulation and others. Link is in the description. Thanks for watching and have a great day. Namaste. Namaste guys, this is CAD Knowledge, and in this video you will learn how to do a thermal simulation in Solidworks for beginners. So to do a thermal simulation, we first need a geometry. So select a plane in which I am going to first draw a sketch and my geometry. 200 by 100. This is the dimensions of our plate on which I am gonna place my heat. Now you can reduce the thickness to 5 mm. After that, what I am going to do is I am going to draw fins in which my heat is gonna transfer. Say 20 mm and 20 mm, and the diameter is 10 mm. Now go to linear sketch, select linear sketch pattern. After that go downwards, select entities to pattern, select this sketch. Make sure the distance is 20 mm and increase the number of the pattern. Now select the y-axis and just increase the pattern. As you can see, they are coinciding, so make sure you are doing that you increase the distance, center distance between them. So increase it and click on this reverse direction. After that increase the number as per your requirement. Here I draw the shape of my fins. Basically I am using circular fins. Now extrude up to the length of 70 mm. Click OK. Now go to SolidWorks add-in, click on SolidWorks simulation. After that go to simulation. Now click on study advisory and make sure you click on this arrow and click on new study. Now select thermal because I am going to do a thermal simulation in Solidworks. Click OK. After that, first thing we need to do is apply material. So right click on part 4, click on apply favorite material, select plain carbon steel. So this material is now plain carbon steel. Now first thing I'm going to do is apply a load. Click on thermal loads, click on heat power. So and select this face. Make sure that the arrow direction is upward. As you can see, these are small tiny arrows and its direction is upward. Now apply a load of 2000 watt. I hope you all know about thermal heat transfer. So basically what I'm doing here, that I'm applying a 2000 load 2000 watt heat here. Click OK and click on convection, and I'm going to trying to cool this plate by air. Click on select all exposed faces and make sure you uncheck the bottom face. After that, go to convection coefficient, enter the value of 20 mm, 20 watt per meter square Kelvin. You can change the dimension as per your requirement. Here it's asking for the bulk ambient temperature. So bulk ambient temperature is the temperature of the surrounding. For example, you are boiling your water, so the temperature of the boiling water is 100 degrees Celsius, but what is the temperature of your surrounding? For example, it is 25 degrees Celsius, so you will enter the value of 25 degrees Celsius here, that is the bulk ambient temperature. So here 273.15 plus 25. Remember, here the units are in Kelvin, so the exact value is 298.15 Kelvin. Now click OK. Our setup is ready, and what you can do is right click on mesh and create mesh. You can increase or decrease the quality of mesh as per your requirement, or you can set parameters as per your requirement, but here I don't need it because my main aim is just to show how to do meshing. So after clicking OK, here you see the mesh. Remember, higher the quality of mesh, higher will you get the quality in simulation result. After that, click on run this study. When you click on run this study, now simulation is gonna happen and you will see how does the heat distribution goes on. Now click on Ctrl plus 8. What I press is Ctrl plus 8. Now a question arises in your mind, how can I see the temperature curve? So there are two ways. The first way is go to Pro Tools, click on Probe. After that, make sure you select add location. Now select the bottom. After that, select stop plate. Now in the similar way, just select the point at the top so that you will get a graph. Now move downward, click on plot. Here you can see the plot graph with respect to distance, and at the top is we got a temperature near about 112.17 Kelvin. Here you can read the temperature. Here you see 1121.26 in Kelvin. Remember, the temperature units are in Kelvin. You can also save the data just by clicking save. When you click on save, your data will get in a Excel file with the extension of CSV. You can change the name as per your requirement. Now click on cancel. Now another method is go to Pro Tools, click on ISO clipping. Now somebody say, hey, I want to only see the temperature that is above 1341. So what they can do is just select the values as per your requirement and it will show the value above the value that you have selected. As you can see here, all the temperatures shown here are above this temperature. Click on ISO 2. Now what you will see is that temperature in between the range of these. Here 1213 it will show the value above the values, and 1317 you will get the values above it. Okay, you can also add or animate it. Sorry, you will not get the animation of this. Animation is not available for this type of float, so you will not get the animation. And you can click on report so that you can make your own reports. If anyone don't know how to make report and want more details, you can just click on the non-linear description, non-linear video description. Now come to the main point. How can we select how to select a particular dia and height so that we get minimum temperature at the top and bed and the best heat transfer. Now this is a question of about design study, so I will talk about design study in the next video or the upcoming videos. Till then, I hope you enjoy your days and enjoy quarantine due to coronavirus. Make sure you learn every day. Thanks for watching and have a great day. Check out the link in the description for more education contents and video links. Thanks for watching and have a great day. Namaste. Namaste guys. In this video, you will learn how to select a particular diameter and a good length so that you will get a maximum heat transfer in uh, simulation. So a question arises in your mind: what is the need and where to use, how to use, and what kind of steps we need to do this kind of simulation. So before I start this video, make sure you check out our previous video, because in previous video I have told you how to do this simulation. If you don't do this simulation before, you can't able to do this whatever I'm going to show, design study, you can't able to do that. So make sure you have done this simulation before watching this video. You can watch this video, the link is in the description. Now, so to do design study, what first need to do is we need to do this simulation. After that, go to study advisory, click on below arrow, select new study. After that, click on design study, click OK. Now here you can see the word optimization. Basically what I am doing is optimization. So the first thing here you see variables, constraints and goals. So variable are basically those things which I want that change, which I want basically change so that I get maximum optimization and better result. So a question arises in your mind, so what are the variables here in this simulation? So let's see what are the variables here. Click on to add variables, click add parameter. After that, when you see this box, go down below and select the diameter. Okay, as you see I selected the diameter, you will get you will see the value. Make sure you type the name whatever you select so that it will get easy for you. Here diameter. Now the second thing I want to select is the height. So search for the height dimensions. Here is the height 50 mm. Sorry. So basically what I have done accidentally, that I select these dimensions in diameter block. So what I can currently do is just type height and select the below one, and now go and select again this diameter. Remember, it is my mistake. If you don't do that mistake, don't worry. Sorry. Type diameter. Now here I am going to change only these two parameters to get maximum heat transfer. So click apply. After that click OK. Now here but in variables you will only see height, not diameter. So click down this and select diameter. Now here you see range with step, discrete value and range. Here I am selecting range with step and range with step. So a question will arise in your mind, what is range with step? So let me tell you what is a range with step. So in basically range with step, you will select you will type a minimum value and maximum value. So and you will type a step of 25 mm whatever you want. Remember, lower the step value, higher you will get the better you will get the result. So let me tell you what it do. For example, assume that my current diameter is 10 mm. Now it will do simulation when my diameter is 10 mm and height is 25 mm. When it done the simulation, when my diameter is 10 mm, height is 25 mm, it will do another simulation in which my diameter is 10 mm but my height is 25 plus 25 mm 50 mm. So the next case scenario is 10 mm diameter and 50 mm length, and a third scenario in which my diameter is 10 mm and my total height is 75 mm. Similarly, now the next case scenario runs in which my diameter is 15 mm but my height is 25 mm. So it will run the simulation with all the given values. You can say permutation and combinations that is basically going on here. So let's change the value to 10. Here you can see total number of active scenarios. Remember, higher the active scenarios, higher you will get a better chance to get a result. But higher the active scenario, higher you gonna take a time. So I'm gonna increase this step value so that my total active scenario will get reduced. As you can see, it is now 15. I am reduced gonna more 20 mm because it is just a waste of time for me. The main aim my here is only that you will learn how to do simulation. Now let's see another things. Discrete value is basically, now when you click on discrete value, it will randomly it will just asking enter the number separated by, for example, 50 mm. You wanted a height of 50 mm and after that you said I want a height of 10 mm, 15 mm, 10 mm. So basically what basically happened here, you will enter the values at which you want, that is the height at which you want just simulation. For example, when you select range with steps, you get a fixed step values and you will get the result. But in this case, you enter individual height values at which you want to calculate. Okay, select and there is range. A range is 25 to 75 mm, but there is no step. So it depends on the Solidworks how to optimize it. Remember, but the main problem with range is the time consumption. It will give you much better result, but it will consume a lot of time. So I don't prefer range. I prefer range with step. Okay, now let's talk about constraint. So basically, when we heard constraint, it means that basically constraint. Let me tell you. For example, click on add sensor. Click on sensor type. Select simulation data. Now down below here you see lots of data quantity, but stress, strain, displacement, all these are useless in case of thermal, because what we need basically here thermal simulation. So what we select thermal. After that select the dimensions, select the select the units as per your requirements. Here you see model max, model minimum, etc, etc. You can choose as per your requirement. Now click OK. Here it is asking what is the constraint. So my minimum constraint is that the minimum temperature should be 25 degrees Celsius. It should not be below the 25 degrees Celsius. Basically, for example, I have give you 100 rupees. Now what is the maximum amount you can spend? You will say 100 rupees. Why 100 rupees? Because that is your constraint. It is the limit that you set so that it don't go to above that. So here is at the minimum constraint is that my minimum temperature is 25 degrees Celsius, but I allowed it to get above 25 degrees Celsius. Okay, so that is what constraint. Now a question arises, what is the goal? Basically what I want to do this simulation, I want that my temperature will get minimum. So what I am going to do is click on thermal temperature, click on Celsius because that's what I want to do. Now Here you will see temperature minimize, maximum and exactly, but here I just want to my temperature to be minimized. That is the reason I am selecting minimize. If you want that your heat transfer is more, uh, if you want that heat transfer is more or at the temperature is less, it depends upon you. So what basically want that my temperature is minimized at the tip. Okay, for that I am doing minimize. If you want to say, hey, I want at the tip that the temperature is maximized, so just click on the maximize. Remember, it is up to you how to do simulation. After doing all this, click on run. Now let's see what's happening in the background. As you can see, it's currently processing the scenarios. Now here you get see you are watching at the table. For example, here the initial height is 50 mm and diameter is 10 mm and temperature at the initial is 1173.7 degrees Celsius. Now here it runs the first scenario. As I told you before, here the height is 25 mm and diameter is 5 mm, and it runs the scenario and you can see the temperature here. Now again it runs the scenario 45 mm and the diameter 5 mm. Now what it will do, it will do the permutation and combination up to 14 scenarios, and as you can see it has done currently 6 of 14 scenarios. Now doing these scenarios you will see that there is temperature at every scenarios, but but what is the main what is my main aim? My main aim is that the temperature will get minimum. So whichever the temperature will is below the 1173.7 will get here in optimal. But currently, because currently the simulation is running, none of it is shown. When the simulation is running, simulation just done, it will show me which scenario is the better scenario. As you can see, it currently doing just one is left. After that it will gonna finish, and 13 of 14 here it done the simulation. Here you will see when my height is 75 mm and my diameter is 25 mm, I got the minimum values. So this is how a design study is done in case of thermal. I hope you like this video. If you have any doubts and queries, make sure you ask comments, and make sure you check out our other videos, for example non-linear simulation and others. The links in the description. Thanks for watching and have a good day. So namaste guys, in this video I am going to show how to do a heat sink simulation in Solidworks. So basically what I'm going to do is I'm going to make a geometry in my hair and do the simulation. So first of all we need to create the geometry. So let's create our part. So here what I'm basically doing, here I'm making a circular chip of a diameter of 30 mm. You can make a bigger if you want, it's up to you. Okay, let's make it reverse direction and make it a little bigger. So click on sketch, edit sketch, and make it 50 mm to give you a better picture. After that exit the sketch. Now click here, click on new part, select the new part, click on the edit component. Now select the top plane of the sketch, click on sketch, press Ctrl+8 for normal screen to the view. Now here I am making the heat sink of my chip. So enter the diameter. You can increase or decrease the diameter as per your requirement. So let's say 55 mm diameter. My heat sink is bigger than the chip. It is not necessary that you make heat sink bigger than the chip. It is up to you that you want to make smaller or bigger. Okay, so select the chip and reduce the thickness to 3 mm and click OK, and select the top face, click on sketch, press Ctrl+8 for normal screen to the view. After that what I'm going to do is select the edge and click on convert entities. Now draw a rectangle, give it a thickness as per the requirement. Here I am giving a thickness of 2 mm and go to the linear pattern select select these, move downward, select entities to pattern, select the edges of the rectangle. Now increase the number of instances, so let's make it to 6, and the distance between these rectangle is 10 mm. You can change the distance as per your requirement. Click OK. After that, click on trim entities and trim the necessary part. Make sure you do it correctly, else during extrusion you might face a problem if you don't do trim correctly. Now trim these. As you can see, that line is here, so it is necessary because during extrusion I want these lines to be present here. Okay, and distance is 2 mm. Now trim here also. Press Ctrl plus Z, click on trim entities, and trim this, and the last line here is this. Now go to extrusion, click on extrude boss base, make it extrusion up to 30 mm. So this is basically our fin. So exit the assembly edit mode. Now in the geometry, so what we can do is go to the simulation tab. If you don't see it, click on SolidWorks adding, click on SolidWorks simulation. Now click on simulation tab. Now click here, click on new study. Remember, I am also going to show some mistakes that beginners do, so make sure you watch the video carefully. So click on parts, right click on part, click on chip material. So basically I am assuming that my chip is basically made of copper. So remember, you can select the material as per your requirement. Here my main aim is just to show how to give material and how to do simulation correctly. Selecting material and other things is up to you. Okay, and I am assuming that my fin is made of plain carbon steel. After that, what we can do is right click on connections, click on contact set. A question arises, why I am selecting contact set. Contact set is basically used in thermal. For example, you want to click on thermal resistance, bounded and insulated. Insulated basically means that if I select a particular area, that is basically act as my insulation. Here I am selecting thermal resistance. A question arises in your mind, what is thermal resistance? For example, here you can see a copper chip and a plain carbon steel. They are the plain carbon steel is placed above my chip. So when my heat is transferred to the plain carbon chip, not all heat is going to transfer properly because there is thermal resistance, surface contact. Due to that, some heat is going to lost. So that is basically called thermal resistance. If you still doesn't understand, I highly recommend you that you read books of heat transfer by Segal to understand the concept, because it is an engineering concept. Okay, now select this here and right click on select other, so that select we don't delete contact set, delete it. Right click on contact set, thermal resistance. So right click here, click select other. So as you can see, I am selecting the top part of the chip. So click on the chip and select the bottom part of the fin. Okay, and move downward, select, enter the value of thermal resistance. So you can enter the value as per your requirement. Click OK. Now go to the thermal loads, click on heat power, select the bottom phase, enter the value of heat that you think is going to enter in your board in the chip. For example, so I am assuming that during simulation that my chip is getting a 50 watt power, so I am giving a value of 50 watt. After that, click on convection. Convection basically means that air is moving around, so click on select all exposed faces, uncheck the bottom part because heat is given at the bottom part. Okay, enter the value of convection as per your requirement, for example 15 watt per meter square Kelvin. Remember, I am going to do a mistake so that you will learn what kind of mistakes normally beginners do. So the result will is going to be incorrect. I will tell you why the result is incorrect. So run this study. As you can see that my result is just came out. So click on result, click on define thermal plots, because currently the temperature is in Kelvin and I am not comfortable with Kelvin. I am comfortable with Celsius. So click on Celsius, and here you can see that the temperature is minus. A question arises, how is possible that a temperature come in negative? So basically what happened during convection, right click on convection, click on edit definition. So basically what happened, that here you see the bulk ambient temperature. Bulk ambient temperature basically means that that it is occurring at a temperature where the room temperature is 0 Kelvin. So you know that 0 Kelvin is a is a temperature that can't be achieved in real life. But here Solidworks inbuilt take the bulk ambient temperature to 0 Kelvin. So change this value to 300 Kelvin, that is near about 27 degrees Celsius. Click OK. After that, click on run the study. Here you see, now I got the temperature results. So let's change the thermal plot again. Click on Celsius, click OK. But here I got the correct result this time. So the bottom part is 19 degrees Celsius and the topmost part is 15.062 degrees Celsius. The reason that the temperature difference is just near about 4 degrees Celsius is that the body is very small. It is not a big body. That is the reason that you don't see a wide change in the gap. So if you want to learn how to select a particular fin so that you will get a maximum optimization, I highly recommend you that you check out the description link of my video, that how to optimize this fin in SolidWorks so that you get maximum heat dissipation from the fin and you will get the better result. I hope you like this video. If you have any doubts and queries, make sure you ask in comments. Thanks for watching and have a great day. Namaste. Namaste guys, in this video you will learn how to do a dope test simulation analysis in SolidWorks. So to do that, first we need to make a part. So basically I am doing all this in assembly mode, not in a part mode. So first of all we need to create a new part. Click on this part, then click here, click on edit component. Now go to the part, select the front plane, click on sketch, press Ctrl+8 for normal view. Now enter the length or breadth as per your requirement. Here I am making a square of 100 by 100 mm and gonna extrude it up to a length of 100 mm. Make sure you select mid plane because it will gonna make easy for us while doing simulation. Now right click on box. Make sure you first exit this part edit component and right click on it, click on float. As you can see I am able to float it now. Now go to mates, select select right plane and right plane of the assembly, click OK, and select front plane and front plane of the assembly, click OK. Make sure it doesn't coincide with the top plane. Now click OK. After that go to simulation, go to new study, click on drop test. After that what we need to do is right click on the part, apply the material as per your requirement. Here I am gonna use plain carbon steel, but you can change the material as per your requirement. After that right click on setup, click on define/edit. Here select velocity at impact. here there are two things. I will tell you both of them. So first let's talk about drop height. So basically drop height means that you are basically throwing your part at a certain height. You will tell what is the height, and here you see two things, from centroid or from lowest point. So basically from centroid means it's center of gravity, and from lowest point means it's the lower point. So basically I'm selecting lower point and select the location of gravity downwards. Click here, click on here for reverse direction because gravity is acting downwards. And here you see two options like normal to gravity, parallel to reference plane, rigid target, flexible target. Rigid target is that one that doesn't deform on hitting the surface, and flexible target is that one that basically deform, and it asking for what is the stiffness and other things. So basically in this study I'm gonna talk about rigid target. Okay, so click OK and click on run this study. After this I will tell you how to do velocity simulation. Basically we give a certain velocity of to our part and see what kind of impact we are gonna see on our part when it strike to a rigid body. Now right click on stress, click on animate. Here you can see the animation. Click OK and right click on displacement, click on show and right click on animate. Now let's talk about another thing, new study, but this time I'm gonna use the velocity at impact. So here it is asking for the direction, in which direction it is gonna the velocity is. So select this edge because it is acting downwards. As you can see the arrow is pointing upwards, so click on reverse direction. And remember one thing, that drop test can do simulation up to a velocity of maximum 500 meter per second. Here you see this value, so we reduce this value to 150, and it's asking for the gravity direction. Again select this edge, make sure it's acting downward, and here it is, and click OK. Right click on part, select material as per your requirement and click on run this study. Here you can see. After this I will tell you how does damping affect when you give the values some value of to damping, how does it gonna affect in the simulation. For example, currently what you have seen is that when a body falls or collide with the surface, it just stick with the surface, it is not bouncing back. It is not, why it is not bouncing back? Because we give damping value 0. If we give value other than 0, it will basically bounce. So after this simulation I will show you how to do damping. And click on animate. As you can see, it's not much bouncing now. Right click on displacement, click show, right click, click on animate. Now let's see what will gonna happen when we give a contacted damping. For example, let's say 2. Okay, sorry. Basically here it asking the value in percentage. When it says 0 to 1, so basically asking the value in percentage. So I have to type 0.2. So click on run the study. Now click on stress, click on animate. Here you see a very interesting thing that all this experiment is done in microseconds, okay, and deformation scale is 1 because I changed the definition. If you saw my previous video, you will realize what it means, deformation scale. I hope you like this video. If you have any doubt and queries, make sure you ask in comments. And there are many other cool videos, for example no linear simulation, you might have seen while watching this video. It's shown here, so you can check out those videos. Link is in the description. Thanks for watching and have a great day. Namaste. Namaste. In this video you will learn how to do buckling analysis on a thin shell in Solidworks, and these are the other things: buckling analysis, when, where and how to use shell manager command in SolidWorks, and how to increase or decrease the frame rate of simulation animation, and last but not the least, how to edit chart definition as per your requirement. And there are some more other things you are going to learn in this video tutorial. So first thing we need to do is create a part. So click on new, click on part, click OK. After that click on front plane, right click on it, click on sketch. Now draw a circle of diameter of diameter 55 mm. You can change the diameter as per your requirement. After that go to surfaces, click on extrude surface, enter the value 120 mm or above as per your requirement. Remember, I am just going to make cylinder of the can, not the top or bottom face, because I am going to simulation on this face. Okay, click OK. After that go to SolidWorks add-in, click on SolidWorks simulation. One more thing, some people might not able to see surfaces in their tab. So what you can do is right click on here. Here you see different kind of things, for example sheet metal, weldments. So if you don't see surfaces, just click on surfaces and you will get the surface tab. After that click on SolidWorks add-in, click on SolidWorks simulation, go to simulation, click here, click on new study, click on buckling, click OK. Now the first thing we need to do is right click on it, click on edit definition. Basically where I am is shell definition. Now let's learn why, where and how to use shell definition. So shell definition is basically used when we're talking about very thin objects, for example plates or uh, things that are less than 5 mm or below 10 mm. Okay, so a question arises, why use shell definition, not the part or other thing else? The reason is that when you use shell definition or shell, you get more high quality mesh, easy simulation, and better result. That is the reason we use shell definition. If you ever get you get a choice between to choose shell definition and a model part, prefer shell definition. Remember, shell definition is only choose when you have a thin part, not other. Here I will enter a value of 0.1 mm because the thickness of the cylinder can is very less, so because of that I am entering 0.1 mm. It is thin cylinder, because of that I am selecting thin. It is not thick, it is not composite, it is a thin. Now click OK. Now right click on it, click on apply edit material. Now go to aluminum alloys. The reason I'm clicking on aluminum alloys is that the aluminum can is basically made of aluminum. So I'm selecting a material, let's say this one. Okay, this one, click OK and close. Now right click on fixture, click on fixed geometry.
This is dollar door
Select this
mechanism.
edge, click OK.
If you want to learn
Now
how
right
to
click on
make
external
store,
loads, click on
just
port,
go to the
select this
link
face,
above
click
provided.
here, select this face. Make sure the value is 1 Newton meter because a high value will gonna uh, create a problem. Click OK. After that, right click on mesh, create mesh, increase the fineness, click OK. Now as you can see, when I click on fine mesh, it create the mesh very quickly and accurately. That is the advantage of shell manager. Now right click on run the study. Here you see that the displacement is quite large is showing on. The reason is that when you do a simulation, the Solidworks shows simulation quite higher than the normal. For example, go to edit definition, click on here, you see it's automatic and the scale uses 1.212. Now click on user defined, click on 0.5, uncheck show colors, click on settings, click here and mesh, click OK. Now right click on animate. Here see the animation. Now let's see how to increase or decrease the frame rate. First thing you need to do is click on stop. Now here is basically the frame. So here basically 5 frame per second. So to increase the frame rate, just enter the value, for example 30. Click on play. The first thing we're gonna do is it will gonna calculate all the frames. Here you see it is calculating. Now it's 30 frames. Now it can show you the animation. And what other thing we learn from this, that uh, that it can handle a load of 20.52 force. Okay, this is basically the load factor. That is the main aim of calculating. Okay, I hope you like this video. If you have any doubt and queries, make sure you ask in comment, and don't forget to like, subscribe and share this video. Check out the description link and you will find more simulation video tutorials. I hope you like this video. Thanks for watching. Namaste. Namaste. In this video, we are going to learn how to do a non-linear simulation in Solidworks. So here, basically I made three parts. Let's see the drawing of each part. The first part, I called it vendor. You can call it or write name as per your requirement. Here, you can see the dimensions so you can make for yourself. Remember, the main thing here in triangle is the triangle only. The triangle total length is 200 mm and the distance from the center is 100 mm and the depth of the triangle is 55 mm. Make sure this point is at the center of this line. It doesn't matter what is the height of this, you can make as per your requirement. All you need to make sure is that the length of this is remain same and there is a fillet of 10 mm at the end is here. As you can see, it's curved, so I just used a fillet command here. Now let's move to the second part. The second part is basically just a line of 300 mm diameter and extruded to length of 50 mm, as you can see. And not last but last part is here you can see its dimension. Its total length is let's see 300 mm and the cut is 200 mm. Its total cut length is 200 mm and again the depth is 55 mm with a fillet of radius 10 mm. I show you these drawings so you can make for yourself and do the simulation on your own. Okay, after that I made this assembly. As you can see, it's properly assembled and it is totally coincident with the planes of the surface. Now after that, press Ctrl plus 8. Now go to Solidworks add-ins, click on Solidworks simulation. After that, wait a minute and you will see that a tab appears of simulation. Click on simulation. After that, click on study advisory. Below the arrow, click on new study. Now move down the cursor, select non-linear. After that, make sure you select static and use 2D simplification. A question that will arise in your mind, that why I am using 2D simplification. If I do in 3D, what it will gonna do, it will gonna take a lot of time. If I use this 2D, it will reduce the time because it's just 2D geometry and it will show me a good result and in a less time. So make sure you select 2D simplification, click OK. After that, it is asking me select the plane in which you want. As you can see, it says selection of plane. So basically a question arises in your mind, what is mean by section of plane and depth. So here I am choosing the front plane. Why a front plane? Why not right plane? Why not top plane? I am choosing the front plane because with respect to front plane there is total symmetry of my drawing. If I choose the top plane, there is no symmetry. Let me show you. Here for example, I choose the top plane. As you can see, at top plane there is no symmetry, but if I click on the front plane, as you can see, there is symmetry on both sides, but in case of top plane there is no symmetry on both sides. If I click on right plane, there is symmetry on both sides, but if I use this plane, as you can see, I can't fix it becomes a cantilever problem and you will not gonna like it. For example, here I click on it, let it 20 mm. Now click on it. As you can see, it is not the problem we are going to do. So because of that, make sure you always click on the front plane. Now press Ctrl plus Z or go to new study. Now go downward, select non-linear, use 2D simplification, click OK. Now select the front plane. I hope you now understand why I am choosing the front plane. If I choose any other plane, then there is no symmetry in the drawing and it will totally waste it. Now enter the section of depth 50 mm. A question will arise in your mind, why the section of depth is 50 mm. because the total width is 50 mm and this symmetry of 50 mm. If I type the value of 20 mm, when I do the simulation and want to see the result in 3D, I can't able to see the result in 3D properly because I select the width of 20 mm, but in reality the total width is 50 mm. So make sure you enter the value of width as same as the assembly or the components. So here I am typing the 50 mm because my extrude is 50 mm. Click OK. After that you can see my 2D geometry. Now what we need to do is apply material. Press Ctrl, click on Bender and die. Right click on it, click on apply favorite material. Select the material as per your requirement. For example, I select malleable cast iron. You can choose any other material as per your requirement and plate die as a 1060 alloy. Remember, always select the plate material something that can bend. For example, if I select the plate die material cast iron, we know that cast iron doesn't bend, they just crack and destroy themselves. So make sure you select a material in such a way that it can bend under the load, or a tensile material. Always select tensile material in case of plate die. Now delete this component set, click delete. Now right click on collections, click on contact set. Make sure you select no penetration. If I don't click on no penetration, what will happen? It will penetrate the body. In my case, I am just doing deformation test, not penetrating anything or removing material. What I just want is deform, like plate bending or sheet bending, etc. This is what I am doing here. So first thing it asks, select the face. So select the bottom of the plate. Now select the bottom of the top of the die. Make sure you select all edges. Here you see that I select in one the bottom of the plate, in another I select the die top. The reason is that because I am creating a set so that my software know where there is no penetration. Okay, when I do simulation, Solidworks now know that there is no penetration in these bodies. Make sure you click on friction. Without friction, your simulation is not gone up to the mark, and you know, whenever you do deforming, friction play an important role. Without friction, you can't deform anything. And make sure select the advanced and surface to surface, because the contact is surface to surface when our deformation is gonna happen, so that there will be no penetration. Click OK. Now right click on it, click on contact set. Now this time we are going to contact set between the plate and the die that is going to bend it. Make sure you click all the edges. Click on friction. You can change the friction value as per your requirement. Click on advanced. Make sure it is surface to surface. Click OK. After that, what I need to do is go to fixture advisory, click on fixed geometry, select this top face. As you can see, arrow showing upward direction, but I want that it moves downward. So go to advanced, click on this arrow. As you can see, arrow is showing upward, so make sure you click reverse direction and enter the value of 80 mm. As you can see, the arrow is pointing downward, so this is basically what I want. So what it will happen, what it will gonna do, that when I do the simulation, it will move this part to 90 mm. Remember, I maintain a distance of 100 mm while doing assembly, so you need to do that. And here select angle plane direction, make sure it is 0. So a question arises in mind, what does this do? So for example, when this body falls, I don't want that it moves in x direction, in the other of these direction. So when I type the value 0, it will only just can go move downwards. Because I click the direction 90, so it can't go upward, it just only go downward, not in x directions. Okay, as you can see, it is x axis, and I click on x-axis 0, and y-axis I just click on reverse direction, so it goes 90 mm downwards. Okay, click OK. Now here go to fixed geometry, click on fixed geometry. Now select the bottom of the die, click on fixed geometry. I think just remember one thing, it doesn't matter what you do while assembling fixed anything or not. While doing simulation, you need to redefine what is fixed or what is not. If you don't, your simulation is not gonna work properly. Again, click on fixed geometry, select this side of the plate so that when the plate gonna bend, these edges don't move. Click OK. After that, just click on run this study, or you can click on right click, apply mesh, or you can create the meshing as per your requirement. Here I just simply want to show you how to do simulation. I'm not going to details. Just ignore this. Here you can see the live preview that it going downwards. Here it shows now bending. Here as you can see it's bent. Now somebody say, hey, I want to see the result in 3D. So what you need to do is just right click on it, click on show as 3D plot. Here you can see in 3D. Remember when I told you select the width of 50 mm and told you what's the funda of doing all this. So here you can see now you understand what's the reason of all doing this. So now let's click on plot tools, click on probe. For example, I want to know what is the stress at this point. So here you can see at the node 2585 the stress value is this at a certain location. Here you can get the sum values, average, maximum, minimum, root mean square value. The root mean square value basically means it is a statistical method to find the best value, so it is a much better value. You can also plot the graph. For example, click on the plot graph. Here I just click on one point. For example, select multiple points. Now go to pro. Here you can see the stress is maximum, and here stress is maximum, that is the first point. After that I go outwards and I select accidentally top of the little top of the plane, because of that shows the graph. I hope this video helps you, and you can do more things. For example, displacement show, and you can just click on animate so that you know what's the better result. Or you can increase as you can see it gives you a clear picture. And strain, if you want to make a report, just click on report. So what we're gonna do, it will create a report for you. All you just need to do is write the name of all these things and logo, whatever you want, and it will create a fully published report for you. You want to do so, create cancel, because, or you can just click on publish. So what it will gonna do, it will gonna open the MS Word and create a full report for you. It will gonna take a time. So as you can see, now it starts. So while doing reporting, let me tell you what kind of things it will gonna show. It will gonna show what are the boundary conditions we applied, and what are the loads, what are the maximum stress, what are the average stress, and many other things. If you want to insert a particular pictures that you want to show, hey, I want to do this thing, you can also do that. What you need to do is, while doing simulation, use while you see, when I click on publish report, you see there's a button, button called add pictures. So you can click on that and add a particular pictures of the simulation images. So it will help to your customer or your research work. So what you want to basically want to show here is currently generating a document for me. Here you see whatever doing in background is basically writing that thing. Now it will show me. Here you can see my Solidworks simulation. Close it. Now tell me the properties of the material that I applied and yield strength, etc. Positions ratio, everything you need to show your customer or you need to show in service. Here is showing the mesh quality. Just remember, higher the mesh quality, higher the better is the result. Here is the simulation results. Here is the strain. Here is basically displacement, and here is basically engineering strength, engineering strain. ESTRN means engineering strain, equivalent strain. Okay, equivalent strain also. And conclusion, you can type conclusion whatever you observe from it. I hope you like this video. If you have any doubts and queries, make sure you comment, and please give me your valuable feedback. What do you like and what you don't like in this video? I hope you like this video. If you have any doubts and queries, make sure you comment. Thanks for watching. Please subscribe and have a great day. Namaste.
Namaste. In this video, we will talk about centrifugal force, what are its effects, and how much it produces stress and strain. So, we are going to use SolidWorks simulation. So, here I draw a merry-go-round. Now, I draw a merry-go-round because it is a very good example of centrifugal force. We can calculate what kind of stress strain and what kind of impacts. Click, first of all, go to Study Advisor, select Static, click OK. After that, right click on part, select Apply Edit Material. Select the material as per your requirement. Click Apply and close. After that, go to External Loads Advisor. Select Centrifugal Force. Now, it says selected reference. Now click here, select this curved surface. After that, it asks you the velocity. It asks you enter angular velocity and angular acceleration. You can choose the units as per your requirements. Here I am going to entering the value 300 rpm. Remember, 300 rpm means in a minute it will rotate 300. It means in a minute it will complete 300 rounds. Now it is asking for the acceleration value. I am entering the value 10. Here you see, here you are able to see that arrow rotates clockwise. If anybody wants to change the direction anti-clockwise, just click on reverse direction. Okay, and enter the value of 10. Now click OK. After that, go to fixture advisory, select fixed geometry, select this face and click OK. When I select the fixture advisory fixed geometry, it doesn't mean this part does not move. It just only mean that it take a reference. If I use roller or slider, the centrifugal force you can't able to calculate. Many people will start thinking that I fixed this part, so how does it will going to rotate? No, it only assume that that this body will rotate and this is the axis that remains fixed. That it means that this axis does not reflect right, left, right, or any other direction. Just it remains fixed in its position. Now go to run this study. As you can see, uh, our stress strain. Here's the deflection. Now right click on displacement, click animate. Stop the animation. Let's increase the frame rate. Click play. As you can see, and remember that maximum deflection is 2.04 10 to the power minus 1 10 to the power minus 1 mm. So the current deflection you are seeing here is actually 500 times or 600 times more than the actual. The reason SolidWorks shows 500 times or 600 times extra is that because so that you are able to know where is actually deflection happening. Click cancel. Now again right click on again click on centrifugal. Uh, now here we have seen a result when we have acceleration of 10 rpm. Now reduce this acceleration to 1. Click OK. Now run the study. Now go to displacement. As you can see, our value decreases. So what it will tell us that if if we increase the acceleration, it will increase our stress and strain. Now let's see another example of a flywheel. Now go to simulations, go to select study advisor, select new study, select study, apply the material, select the units as per your requirement, click OK. Now click run this study. As you can see, uh, here the reflection is maximum, so we get an idea. Now right click on it, click show, and here the displacement is maximum, so it means here the maximum deflection we get. And in stress case, here the stress is low, but here the stress is high. You can from the color bar check what is value near about. I hope you like this video. Thanks for watching and have a great day. And please don't forget to subscribe this video so that it motivates us to make better and new videos. Thanks for watching and have a great day. Namaste.